All right. Why am I talking about it? I don't know. All right, let's write everything down that I write down, please. Are you okay? I know.
I can't sit for very long.
I get it. I know you're not happy. It's gonna be okay.
I know. I have to stand up.
Here we go. We're gonna write down. So we're gonna go K plus 1. We're gonna.
Are these
Which way?
Notes?
These are notes.
No.
Oh, new notes. Yeah. Is that good? Is that better? I need to use the whole board. So.
What's the title?
Okay. We're just continuing in our note.
I just said new notes and you said yes.
I don't know how to answer that. I guess.
No.
It's. I guess no. It's the same topic, but new notes for today.
No. Doesn't count.
Sorry. CL minus 1.
Oh my gosh, that's funny.
These you don't have to put it all across the paper like me. You can go underneath. It's fine. Just leave space. Hey, listen. You guys take notes how you need to.
I gotta scribble it out. Thank you.
Oh, don't do this.
Okay.
Yeah, let's try this again.
Okay. You're gonna learn a whole lot of chemistry here. Get excited.
Do we need like a lot of space?
If you're putting them one on top of the other, yeah, leave at least like 5 lines.
Oh, we're good.
You need a lot of space underneath. All right. How many protons does potassium have? 19 protons. How many electrons? 19. What about K plus? I was hoping we could do this as like a class. Are you still copying things down? Is that the problem?
I am.
Okay. I'll wait another little bit here. So I want everyone chanting like a weird chemistry cult.
No.
Can I quote you on that?
Yeah, nothing.
Sure.
Chanting like a weird chemistry cult.
Yeah, but it has to be chanting in chemistry class, not like in real life.
I can't just go out in the streets and start screaming potassium.
It was my daughter's birthday yesterday, that's why I wasn't here. And it's a big deal, she turned 1. So we were trying to sing happy birthday to her.
And she just started crying.
Very good. We were trying to sing happy birthday to her, but she started crying as soon as we all started.
That's hilarious.
Well, kind of, but it's because well, think about it, and I described it this way. It was kind of funny. So it's a baby. She has no idea what's going on. You turn the lights off. You're real quiet. You have these burning, glowing things sticking out of something. Everyone's looking at her. She's by herself at one end of the table, and then all of a sudden we start chanting. So think about it. It's like a weird thing for a baby who doesn't understand what's going on. So baby's crying. I mean, we knew it was going to happen, but anyways. The chanting made me think of it.
The chanting birthday cult.
Back to this. Potassium plus 1. How many protons? 19. Thank you. Electrons?
19.
18. CL?
Wait.
17. 17. Very good. 17. 18. Good. Come on. Oops. What did I do wrong?
E.
Come on, let's go. Everybody. 16. What about here? Come on. You guys are lame.
I can't write it down.
20.
We just did this. That's why I'm going quick. We just went over all this.
Well, I
Okay.
just went ahead.
It's the same ones from your right. To be fair, you have to write. It's hard to write and chant at the same time. All right. Now, this we already went over, but now we're going to learn something new, and I'm going to tie it into radius, which is what the rope is for. All right.
Sweet.
Now, if you go to the electron configuration for each one of these, well, for K, Cl, S, and Ca, let's write it down. Amanda. K. Electron configuration.
That? 2, 8.
In the bottom of the box, there's an electron. Yeah.
I get that.
2, 8, 8, 1.
Okay. What about Cl? Kieran.
Hold on. I'm writing down the other one.
287.
CL?
Yeah.
Let me find that.
287.
It's 287.
Yeah, I just want to make sure he's good there. Okay, sulfur. Lexi.
286.
286, good. Calcium, Andrew. 2882. Yes, speak up next time. Thanks. 2882. Very good. All right. Now, first of all, what do these numbers tell me?
The number.
That will tell you how many shells it has.
Don't they add up to
The
Number of electrons, you mean?
Yeah, that's what I meant.
Which happens to be the protons if it's an atom, so you're not wrong. But why are they separated? Each shell, right, you can kind of see where I did this earlier today. So if I have my positive nucleus, what else do we know about the nucleus? Let's review. It's positive. No.
It's more.
Small and
It's
massive.
more.
All right.
Massive.
It contains all the mass. It is positive. It contains all the mass. It is dense. And the atom is. This is the Rutherford gold foil business. Last one. The atom is mostly empty space. I'm going to say those again. Nucleus is positive, contains all the mass, it's dense, bless you.
Bless you.
It's dense, and the atom is mostly empty space. Back to this. Here's our little dense, massive nucleus. We have 1, 2, 3, 4 shells for potassium. The first shell has how many electrons? 2. What's the second? 8. What about the third? What about the fourth? Okay. Now,
So we're drawing that?
you can if you want.
Well, do we need more room under there?
I'm gonna do this again, tomorrow when we talk more about radius. But that's it. That's the last thing we're putting. So you might as well get it down. But now we have to use a little logic here. True or false? I didn't ask the question yet. Positive charges are attracted to negative charges.
False.
True.
True.
Wait, oh, wait,
Opposites attract. Very good. Okay.
I already know what you're gonna.
Why would I ask this question?
I messed up.
Because the.
Morgan,
Oh,
why would I ask true or false positive charges are attracted to negative charges? What does that have to do with what we're learning and teaching right now? Oh.
I don't know, in the back of the room now, I can't really hear.
Right, so now you're zoning out. Got it. Let me refresh your memory. So we just said the protons are in the nucleus, so the nucleus is positive. We have all these electrons outside of the nucleus. What's the charge of an electron? Try again. Negative, very good. So why did I ask that question? True or false, positive charges are attracted to negative charges? The answer is true. Why did I ask that question?
I don't know, I just don't hear it maybe.
Because the nucleus is positive and the electrons are attracted to the nucleus.
Good, Willow. I'll let you off the hook. The nucleus is positive, the electrons are negative, they are attracted to the nucleus. The marble lab, you guys just did it last period, the other lab's doing it tomorrow. All the dots should be close to the nucleus. Okay, there's a method to my madness here. So, out of these 4 shells, think, do not say it out loud, Cannon.
I'm gonna say it.
Okay? Yeah, you might too, actually, so don't, and you too. You guys usually have good answers, but keep it to yourself.
Do
please.
I though?
Yes. Everyone in here actually, whenever you offer up, have pretty good answers.
I
So
just guessed.
keep it to yourselves, please. Which shell or energy level is most attracted to the nucleus, and which shell is least attracted to the nucleus? Forget all of these, just focus on potassium. I'll ask it again. Which shell is most attracted to the nucleus? Which shell is least attracted to the nucleus? And you have to explain why. I'll give you 10 seconds. That was 15 seconds. Raise your hands if you know the answer. Olivia, thanks for raising your hand.
The one closest to the nucleus is most attracted to it. The one furthest away is the least attracted to it.
Why?
Because one is closer and one's further away.
Fair enough. I'll give it to you. Yes, very good, Olivia. Good job. Thanks for volunteering. So, this is a magnet. If I hold it here, is it attracted to the board?
No.
No. Okay. If I hold it here, I'm about maybe a centimeter away. Is it attracted?
Yeah.
Yeah. I let go, it falls a little bit, but then it's attracted. So the closer a magnet is to a piece of metal or opposite poles of a magnet, the closer they are, the more they'll feel the attraction. That make sense?
Yeah.
Okay. Same thing for energy levels. Does anyone see where I'm going with this?
Yes.
You do?
Kind
Go ahead.
of. Oh.
So why do we need to know this one is the most attracted, this one is the least attracted? Because now we're going to talk about K plus 1.
Does it lose that last
Hold
one?
on. Caroline's on a roll here, I think.
Caroline's on roll. My bad.
But it is your gold star day.
Yeah.
I'm just kidding. I know.
What do you think?
Because you're adding
No.
a different charge.
Except for Trigon.
So if this lost one electron, which electron does it lose? Does it lose one from here,
Oh.
close, or does it lose one further away? What makes more sense?
Further away.
Right. So you were right. So good job to everybody who helped out there. What would the electron configuration be?
288.
288. 288. You need to be able to do this on your own. You need to be able to not only tell me how many protons, neutrons, electrons these ions have, but also tell me what the electron configuration is. All you need to remember is one thing. The valence shell, right, this here, the valence shell, same thing here, the 7, the 6, that's called the valence shell, valence electrons. The furthest away from the nucleus, the outermost shell, whatever makes sense to you, that is the one where electrons either come or go. You can either lose or enter that shell. The inner electrons, these 3 right here, never change. Those 2 never change. These 2 never change, those 3. So all the shells inside that stay the same, just that outer shell changes. Why? Because it has the weakest attraction from the nucleus. Does that make sense? I hope. Kristen, what is the configuration of Cl minus? 288. Very good. It gained 1 electron. Where did it gain? The valence shell. S minus 2. Amber, what do you think?
2, 8, 7,
Close.
6,
Go the other way.
8.
8. Very good. 288. So it gained 2 electrons. That's where it gains the 2. Okay. Now the hardest question of the day, Marlena. I'm being facetious.
288.
Very good. 288.
Why is that the hardest?
I was joking. That's what facetious. That was being
Facetious
sarcastic.
means sarcastic.
Yes.
I didn't know that.
I just like saying it. All right. So all ions have the same electron configuration. 288.
Oh, I just realized that.
Who's it gonna be? Who have I not talked to?
Plus
Autumn, I don't think I called on you yet. Can you please tell me what noble gas also has that configuration?
Oh,
It's right there.
Argon. Very good. Argon. Here's the deal. Give me 2 stars, please. You can put it underneath all this. Okay? I'm just putting it up here. Just I don't feel like erasing all of it. So this is the concept here. All ions attempt to form
Argon.
a noble gas electron configuration. Electron configure. Oops. Where's my CON? Electron configuration. I have more to add. I'm just going to erase that. So all ions attempt to form a noble gas electron configuration. They all can't form argon because how many electrons does argon have?
Argon?
Yeah. 18. So there's 118 elements. Not all of them can have 18 electrons. So this just happens to be these 4, but all the other elements will form different electron configurations, different noble gas. But all ions attempt to form a noble gas electron configuration. I'm going to keep writing here. This is called a complete octet. Put that in quotes. Complete octet. Or, another way to say that, or a full valence shell. A full valence shell. So the goal for every single element that has ever existed is this. They want 8, or if they can't get 8, they at least have a full valence shell. I'll explain that in a minute. So they all want to be like a noble gas. Why? What did we learn about noble gases? They're stable. Very good. This is called a complete octet or a full valence shell. Did I erase this? Hope so. Full valence shell. Couple stars here. This allows the ion to be stable. To be very stable. Very stable. So anytime a chemical reaction occurs, anytime, any reaction you see, if I burn a piece of paper, that's a chemical reaction, this is happening. The atoms in the paper are trying to form their full valence shell, their complete octet, so they can be stable. That's why anything happens as far as reactivity is concerned. So this is the key. They all want to be stable, meaning they don't react. That's what that means. They don't react if they're very stable. So you actually learned a whole lot of chemistry there, a ton of it. So what elements cannot form a complete octet? Who can't possibly have 8 valence electrons? Hydrogen can. Good. Who else?
Helium.
Helium can. Who else? Lithium. Who else? Beryllium?
Magnesium.
Nope, magnesium can.
Or that.
Like all these gases.
I'll give you a hint. If you look at the electron configurations on the periodic table,
Carbon.
it's the ones that are below carbon. Carbon actually can. How many valence electrons does carbon have?
6.
No. Valence electrons.
4.
4. What's the charge in the top right corner? So 4 gains 4, that's 8, right? Look at B, look at boron. How many valence electrons? 3. What's the charge? Plus what?
I can't see. 3.
Plus 3, look up here. Boron is 2-3, correct?
Yeah.
What's B plus 3? Just 2.
Oh, I said 6.
That's a full valence shell for B. That's the best it can do. Here's why. If you look at everybody's electron configuration except hydrogen, they all start with 2. So that first level can only hold 2. So if boron has 2, that's full. We'll talk more about it tomorrow. So don't forget, looking up those 2 words, atomic radius, ionic radius. So tomorrow, stay in the seats.